Hey everyone, the project I was thinking of doing is that, well, I was working on an amp the other day and I just got it all working the way I wanted it to, and it was just a cheap one. It was part of another project I was working on, and I burned out the main amp by hooking up to my dummy load backwards and then grounding through the scope. And so I wanted to build something to kind of prevent that from happening again. And it's something I've been thinking of for a while, but I wanted something that's gonna give me a switch where I can switch between going to speakers, going to an 8 ohm load or a 16 ohm load, and just give me the ability to switch back and forth, and so that I'm not always just connecting up here with my scope and have these weird wires coming off here. And then what I want to do is I want to have make it so it's easy to kind of work with different kinds of stereos and amplifiers, and you know, try them on the speakers or try them on the dummy load, watch them on the scope, and just kind of make it easy to do that. So I've got myself a bunch of parts here that I ordered, nothing too expensive, and I got myself a piece of aluminum plate, and let me show you a little more about what I'm going to be doing. So really what I want is that I have a signal coming in, and I want to be able to use a 1/4" jack like this, right? And so that then instead of just having this weird lead soldered to something soldered to my dummy load, instead I have a series of the 1/4" banana plugs that have different types of ends on them. So because some of the speakers have a nice thing you plug in, other ones you have to clamp into the back of the speaker. And so I want to be able to use different banana plugs, use a banana plug on one side, but then have different wire ends, so it makes it easier to connect to different speakers. And in fact, it might be nice to have a banana plug with just a couple of alligator clips for when you're working on a guitar amp and you just want to clip it right onto the output wires. So I want to make that really flexible. So I have here, so I have my banana plug coming in, and then I want to be able to have a switch where I go to an 8 ohm load, to a 16 ohm load, or a speaker right here, and I want to do this in stereo. And then I want to make sure that I have a speaker protect circuit in here, so if I'm getting an offset on my output, then it's not going to wreck my speakers, and as a safety precaution. And so that's generally what I want to do. So I've got these, I've got a switch that's going to help me do that, I've got some resistors here, some connectors for speakers, and I also want to be able to come kind of raw off these and go right to my oscilloscope, and put those down there, and my switch here, and then my speaker protect in between. So this is like a speaker protect circuit I bought, and I got it off eBay. They're very inexpensive. I'll have to do a little bit of screwing around to get this to work because it takes 5 volts AC in, and it's really made to go inside a stereo and to go off I think the circuit that runs the lights. But either way, I can either use AC, or else I can just connect beyond the rectifier. Should be no problem. I'll figure that out. But it should be pretty easy to use. And then I'm going to mount that all on this aluminum plate, and so the plate is actually going to act as a night heat sink for these resistors. And I'm not going to put a fan on it yet, but if I do find that that's getting hot a lot when I'm doing my testing, I'll just put a fan on the back and just blow air across this, and I think that'll be sufficient up into you know, getting above 50 watts. This here is a 50 watt resistor, and so this should be plenty of heatsink for it. And if not, then I can always work on that later. Anyways, that's a general outline of of the project. Okay, so I got it all drilled out, cleaned up a little bit. Then I did this bend here. I just cut this on my table. I don't have a metal shop, but I just cut it on my table saw, and then I just put a slight cut in the back here, and then folded it along that cut there. You can kind of see it a little bit, but that made that kind of came out pretty nice there. That would have been hard to bend otherwise. Anyways, so I'll just start assembling stuff into it. Okay, got those in. So these are my inputs. Now the outputs. That should be, I'm a little curious how these are going to go here. Yeah, so I had to make these 1/2 inch a piece to get everything to fit in, but that's okay. Now we're going to put this in here. This is kind of a weird set of hardware. So that's in there pretty good now. I'll put the second screws on after I figure out how to connect something onto here. Now I have my inputs, my speaker outputs. Now I'm gonna figure out how to mount that in there on the back side. So a while back I bought this little kit with all these little hold-offs, and it's super handy. Give it a big thumbs up. Okay, so I got that on there with the hold-offs. I'm not going to put the nuts on yet because it's on there pretty tight, but I want to move this LED to the front. Alright, so I'm just mounting these resistors on here, and so I'm just going to put a little heatsink compound on the back, and that'll just help it transfer heat. It's not going to be great because these are not that finished that well, but it'll be enough. So I had to do a little more drilling. I forgot. So I want these to go out to the speakers, but then I want to have a way of connecting up my oscilloscope to the raw inputs. And so really it's going to go straight from here to the switch, but also over to here, so that then your scope can always be looking right at your signal all the time. And so I forgot to put those, so I put them over here. And then I'll just like stick wires out from them that I can hang my clip on them. Alright, I think that looks pretty good. So, I think that missing some things. So this actually is a 12 volt regulator on here, and then I don't have any of the diagrams that's supposed to go with it, but and then right behind it is a rectifier and a couple filter caps. And so this is a 7812, so it's a 12 volt regulator, so I got to find an AC source that is enough to feed this guy. Okay, so it's time to do a little bit of wiring, and first thing I have to do is figure out what this switch is up to. Okay, so it looks like this one, or this one and this one, and this one and this one are the input, and then each of these then is the output. So I'm going to connect these to here and here and here and here, so the right and left behave the same way. Okay, so that's our first set of resistors wired in. I'm using black for one ground, white for my other ground, and green and red for my two positives. Red is right, green is left. We come in here, so really in this first position we should have 8 ohms across here. Should have 8 ohms and 8 ohms. Perfect. Okay, so so this is where I'm going to hook up my scope when I want to look at stuff. And so I just connected all the scope inputs directly to where the signal comes in. Alright, so there it's all wired up. First one's going to 8 ohms, 16 ohms, and then the third one's coming to here. Then that leaves 2 spots open for the future if I want to put in something like an attenuator or something like that. And yeah, I think it's looking pretty great. Okay, well, I've got one transformer that's 9 volts AC. Then I've got one that's 14 volts AC. I tried them both. The 9 volt one rectifies to a little below 12 volts. The 14 volt one rectifies to about 18 volts. So at the 18 volts, this thing runs really hot. So if it's running hot, it's wasting power. And this one runs a little bit below the 12 volts. So this is meant to be in a stereo. And I think that's why it's got the AC input. And so I'm just, because I think you're supposed to run it off the light circuit or something. But I think what I'm going to do is I'm just going to pull out this regulator here, pull out this rectifier, and just kind of jumper them across. And then I'm just going to use a straight 12 volt switching DC power supply. And I think that's going to be, this one's 12 volts. And so that'll just that'll regulate the power for me. And it's just going to be, if I leave it plugged in, it's not going to be sucking down energy like these other two. So that's what I'm going to do. So if I look at the circuit here, you've got the connector here. And then it looks like it comes right into a little bridge rectifier that's all inside this chip here. And then that goes, I'm sure it's got filter capacitors there. And that comes into the voltage regulator. And so then I get my 12 volts out. And my plus and minus there. And so what I'm going to do is I'm just going to jumper from here and just jumper all the way over to here and jumper this here and just eliminate all that DC rectification stuff. I don't think I need it because I've got this going on for me. And there it is. I just put these jumpers across here so I can still use this, and then I have my 12 volts coming in, and I tried it out. It's not much to look at. I plug it in, the light goes on, off, and the relay goes off because there's no offset, obviously. But yeah, so I'm happy about that. Took me a little bit to get here. So I want to put a little power light on for this module. So let's see if oh yeah, oh that looks sweet. Yeah, they were throwing these away at work, and I thought, man, that would look nice in my little control box. But it's just got a 1K resistor here, and I just soldered that right in, and then drilled some new holes here, which is getting harder and harder with all these wires in here. Yeah, that looks nice. So this one I needed red, but they were all green, so I had to I just heated this up, and then the plastic came out, and I just put a new LED in and then put a little epoxy in there. I think that's going to be pretty nice. Okay, so here's got the indicator lights on. This one's for power, and this one's for when the speakers are cut out. And so it's a soft start, so it'll be off for a second, and come on, you'll be able to see a light. And when that light goes off, you can hear the relay click. I think that looks pretty sharp. Okay, so I'm just making my my cables, and just keeping it really simple on this one. I've just got a regular end, and here I've just got a banana plug. And I'm going to just put a little shrink tubing on it so that I can tell right and left apart, and then I'll just use a different colored shrink tubing on the other one. Okay, so I got my cables done. So here's the idea: is you just have a cable like this, and you can put whatever ends you want. I've got the plus and the minus marked out, and you just plug it right in there, and plug it into the back of your stereo. So I'm just going to show you how the speaker protect is working now. So I'm set up to go through the speakers, and so I have my signal coming in through my signal generator here, and it's about 4 volts. It is 4 volts peak to peak. And so if I come to my offset and I set the offset to 400 millivolts peak to peak, you can see the signal's coming up, but we still haven't cut out. But if I increase that offset, you see how it's going up, and then when I get around 500 millivolts, you can see that the light comes on and you hear the relay click out. So around 500, 600 millivolt. And then the other thing is that if you go in the opposite direction, and I don't know if it's true for all those boards, but here if I come down, you see a speaker protect shuts off, but then it doesn't come on again until you get to about a volt in the minus direction. So I'm not sure what to think of that, but yeah, so it's about 500-600 millivolts in one direction and minus a volt in the opposite direction. So I think it really does provide a nice protection for speakers coming in here. Okay, so I've got my Pioneers here hooked up. What are they? CS G403s. Got them free from a relative. Didn't like the size, if you can imagine. Then I have a Onkyo amplifier from the early 80s, and have the speakers hooked up through these, and they're coming into here. And right now I have them going into the speakers, and you can see that I just have my scope probes hooked up to here. I can just leave those hooked up to there. Alright, so here I'm going into the speakers, here I'm going into 8 ohms or 16 ohms, and here I'm going into 8 ohms. So I'm dumping into those resistors so I can work without the noise. And if I want to go back to the speakers, super easy to do. I can leave it all hooked up, and I've just got it clamped up now, but I'm going to have to I'm going to screw it in and move it back. And yeah, and so that the beauty of it is then every time I've got a different kind of thing that I need to hook up to, I can just create a different set of banana plugs like that, and not have to go through all that work of clips and all that mess that comes with it. So here I'm putting a signal, 300 millivolt signal into the input of the stereo, and I've got it turned up quite a bit. And you can see where this is really handy because I have it turned on 8 ohms, and already I'm at 9 volts RMS, and that would just blow your ears out. You couldn't stand it. But look at this amplifier. When I get up around 20 watts, or 13 volts peak to peak. It just goes into oscillations up to the rail. But I can easily see that with this, and here you can feel it's starting to get kind of warm here. So there it is, my handy control panel for testing amplifiers, and it's something I've been thinking about for a long time, and I'm glad to finally get it. Make it a lot easier to test these things. I still have my giant resistor back here for when I'm testing really big amplifiers. But yeah, easy access, for easy way to connect things to it, easy to switch between the different outputs, protection for your speakers. I think it's really going to be nice cleaning up my bench, getting out all these, helping reduce the clutter. And so thanks for coming along while I was putting it together, and if you liked it, please subscribe and hit like, and till next time.